Hello, and welcome to this problem on compound interest. The problem we're solving is the following one. What amount invested today would yield $175,000 in 11 years if it were invested at 3.81% compounded semi-annually? And we need to round the answer to the nearest cent. Compound interest is a procedure where interest is calculated periodically at regular intervals known as compounding periods, and reinvested to earn interest at the end of each compounding period during the term. In compound interest, the interest earned in the previous compounding period also earns interest in subsequent compounding periods. So here in this problem, we have that certain investment will yield an amount of money, so that's the future value of an amount. The accumulated value or maturity value, have 175,000. And that maturity value comes from using the nominal interest rate 3.81%, that is compounded semi-annually. So here we have J equals 0.0381, decimal equivalent of 3.81%. And that nominal interest rate is the quoted or stated interest rate per annum on which the compound interest calculation is based for a given compounded period. Now we can get the periodic interest rate, the interest rate for a given compounding period, by using the nominal interest rate. We find I, the periodic interest rate in terms of J, doing J divided by the compounding frequency, and because interest is compounded semi-annually, the compounding frequency is 2. So we take 0.0381 and divide it by 2. And when we perform that division, we find the number 0.01905. Okay. Now, because we have that this investment, an amount of money was invested at the beginning of a 11-year period, we're looking for the initial amount or present value of the money. That's what we're looking for, what was invested. And we need to know a relationship between that principal amount or present value and the future value of an investment. It turns out that the present value can be written in terms of the future value using future value divided by 1 plus periodic interest rate to the n, where n is the total number of compounding periods during the term. In this case, n is the total number of compounding periods during the term of 11 years, and interest is compounded semi-annually, so n was going to be the compounding frequency, so 2 multiplied by the time in years. We have 22 compounding periods during 11 years. So to find the present value would have to start with to get that the accumulated value of maturity value is $175,000 in 11 years is given by 175,000 divided by 1 plus 0.01905 to the 22. And when we compute this number using a calculator, we find the value 115,541.2856 and some other numbers. And because we need to round the answer off to 2 decimal places, we use 115,541.29 dollars as the approximate value. Okay. Based on this, what we can say is that the amount of $115,541.29 should be invested today to get to this value, 125,000 in 11 years, if the interest is compounded in a way that we have 3.81% compounded semi-annually. So this is the answer to this problem. Right, thank you for watching. If you have questions, please write comments or contact me, and I'll be happy to help you. Bye-bye.